Okay, so factoring quadratic expressions, we have already factored items that are in ax squared plus bx, and the c value is 0. And we did that with things like 45x squared minus 20x. And we can look to see what is common to both of these. And we find out that we have a 5 in common as well as an x. So we can take out a 5x, and then you ask yourself, 5x times what is going to give you the 45x squared that you see up top, and that would be a 9x. Bring down the subtraction, and then 5x times what would give you 20x, and that would be 4. So we did that a while ago. Then we've been practicing where we're factoring ax squared plus bx plus c. And we've looked at using the guess and check method. Okay? So use guess and check. So let's take a look at this first problem. 14x squared plus 33x minus 5. So we're going to do, first what I do is I take a look at ax squared, bx, and the c value, and I see if there's anything in common. They don't have an x in common for all three of them because this doesn't have an x. This is even, but these are odd. There's nothing else that they have in common. They cannot all be divided by 2 or by 3. So what we have to do is just start going to the guess and check method. And I come off to the side and I think, well, 14x squared, I could do 2x times 7x. I could do 1x times 14x. I'm going to try the 2x times the 7x first. And then when I take a look at the negative 5, well, that could be negative 1 times 5 or 1 times negative 5. So I'm just going to do some guessing. So I'm going to put a negative 1 here and a positive 5 here. And I'm going to check it. So this gives me a negative 7x. This gives me positive 10x, and when I add them together, that's not going to give me the 33x. So I'm going to erase this. I'm going to erase this, and now I'm going to do some switching around. So I'm going to do plus 5 and minus 1. So I'm going to try that first before I'm going to switch these two around like I just did before I switch and change these to 1 and 14. So I'm going to try this first, and let's see. That's going to give me the 35x, and this is going to give me the negative 2x, and that will be negative 33x. So the final factored form is 2x plus 5 in parentheses, and in the second parentheses 2x minus 1. So this is factored form right here. So this is our factored form. And this right here is our expanded form. Okay, now let's take a look at this problem. 12x squared plus 87x plus 90. And I want to factor this. So when I look at this to see if they have anything in common, I notice, oh, that's divisible by 3. 87 is divisible by 3 because 8 plus 7 is 15. 15 is divisible by 3. And 90, of course, is divisible by 3. So I'm going to take a 3 out. I can't take an x because this last term does not have an x, so I can't use that. So I can't take the x out. So now I'm left with 4x squared plus, So then you have to find out what 87 divided by 3 is, and that is 29x plus 30. So the 3 is going to stay on the outside, and now what I'm going to do is I'm going to take what's on the inside and I'm going to factor that. And I have to take a look and know that I could do 4x times 1x will give me 4x squared, or 2x times 2x, that will also give me 4x squared. I'm going to, since I came up with 4x and 1x first, I'm going to try that first. Remember, 1x and x are the same. Now, I have to come up with 30. So 30 has a bunch of different ways. 30 can be made up of 5 times 6, 2 times 15, 1 times 30, 3 times 10. So I'm just going to try. So I'm going to try 5 and 6 to see if that works. So this times this is 5x. This times this is 24x. Add them together, and there's my 29x. And it does indeed work. Since it does work, I'm just going to get rid of this, because this really has nothing to do with algebra in any way. It's just helping us check. And now what I have is, this is our factored form. And that is completely factored. Some students may give me something like this, 12x plus 15 times x plus 6. But on something like this, I would subtract 1 on a quiz or a test, and I would say not factored completely. That's what I would say. So this right here has to be factored all the way down. And what you can do is take a look that a 3 can be taken out of both of them. So if I take a 3 out there, I'm left with 4x plus 5, and then this is just x plus 6. So make sure that you are factoring completely. Okay, the next thing we're going to take a look at is factoring the difference of squares. Now, difference, again, in math, is subtraction. Squares, we mean perfect squares. So we've talked about this in class already. So we could do 49x squared minus 9. And we can take a look. 49 is a perfect squared. X squared is a perfect squared. 49 is made up of 7 times 7, so 7 times itself. X squared is made up of x times itself. And then 9 is made up of 3 times 3. So since I know that this is a difference of squares, I know that I have 2 parentheses, and this would be 7x minus 3 and 7x plus 3. And when I look at this, I notice that there is no b value. So that means the b value is 0. So when I check here, this is going to give me a negative 21x. This is going to give me a 21x. And when I add them together, it's going to give me 0x, which is just plain 0. So I know that that does indeed work. And so again, I just need to take a look, and I just need to get rid of what's down here, or write down that the final answer is 7x minus 3 times 7x plus 3. So a difference of squares. Let's do one more. Let's try 81y squared minus 100. Well, I take a look. There's 81. It's a perfect square. Y squared is a perfect square, and 100. And notice it's a difference. This only works when the perfect squares are being subtracted. So this is going to give me 9y minus 10 times 9y plus 10. And again, if we check, that's going to give us negative 90. That's going to give us positive 90. Negative 90 plus 90 is going to give us 0. So our b value is 0. And one last one. Let's take a look at 169m squared minus 196. Well, 169, I know the perfect square for that is 13. 13 times 13 is 196. So the square root of that, the square root of 169 is 13. I know the square root of 196 is 14. So here, I know it's going to be 13m minus 14 and 13m plus 14. So hopefully you're taking a look and seeing what patterns there are for difference of squares. Make sure you are able to factor. Of course, not everything can be factored. There are some situations where you have, let's say, 5x squared plus x plus 7. So when I take a look at this, it's definitely not a difference of squares, but when I take a look at this and I try to see, I know I can get 5x and x, and I can get 7 and 1. Well, this is going to give me 7x, that's going to give me 5x, it won't give me just 1x when I add them together, it'll give me 12x. So this does not work. So I'd have to try something different. 5x plus 1 and x plus 7. Well, this is going to give me 1x, but then I also have this, which is 35x. So when I add those together, I get 36x, so that does not work. So here, this cannot be factored. Not every quadratic expression can be factored. So just something to be aware of, just like every fraction can't be factored.